Welcome to today's lesson. We're going to be talking about the periodic table and how it's put together. So on the board here, what I see is a very blank periodic table, and I've broken it down into three main regions. Those three regions being region A, which is from the far left of the table to the stair-step line, which you might have in your periodic tables and you might not. If you don't, I'll show it to you here on one of the periodic tables. Anything from A over to the stair-step line minus hydrogen, way up here at the top, are metals. And we'll talk about properties of metals later, but basically metals are shiny and lustrous and conduct heat and electricity very well. Section B are the elements that border the stair-step line, and it's not every element, and the point here is not for you to know which ones are which, just that they exist. But along stair-step line B, we have the metalloids. I've went ahead and I've drawn in the stair-step line. So the stair-step line extends between boron and aluminum, and then it zigzags along here. So for instance, if you can see the color changes here, I'll zoom in here a little bit. And you can see there's two slight different greens here. The greens represent the metals, and the olive darker greens represent the non-metals. So you have boron and silicon, germanium, arsenic, antimony, tellurium, polonium. These are all metalloids. Metalloids have properties of metals and non-metals. So your typical non-metals are in region C. Non-metals are things that don't conduct electricity well, and they don't conduct heat well, and they're usually liquids and gases. The ones that are solids are not shiny like metals are. They're kind of dull. If you hit them, they'll tend to shatter and break. So those are your three big regions on the periodic table. Each entry on the periodic table conveys a lot of information to it. Here up at the top, every good periodic table is going to have a symbol. Some periodic tables are going to have the name. The two pieces of numerical information that are on every periodic table are number 6, the atomic number. The atomic number is abbreviated capital letter Z. So if you see me ask for what is Z equals 13, Z equals 13 would be aluminum right here. Z equals 31, gallium. Z equals 44, ruthenium. Z equals 79, Au. So we're just talking about atomic number there. The decimal number is going to be the mass, and it turns out that different elements are called isotopes. Isotopes are different masses of that same element. Every element has the same number of protons, which is indicated by the atomic number, but they'll have different neutrons in them, giving them slightly different masses. Periodic tables will have other things in them. This right down here is something we'll learn to deal with later. It's called the electron configuration, and it tells a person on each shell what type of electrons there are and how many there are. We're going to take a look at the periodic table. We're going to talk about families. This should mostly be a review, but for some of you it might be brand new. Starting over on the left, we have this first family here that I've highlighted in blue. These are called the alkali metals. Alkali metals are going to be, we have lithium and sodium and potassium and rubidium. I personally include hydrogen in this family, even though it's not a metal. You could call them the alkali elements. I do that because hydrogen chemically behaves like the alkali metals in certain ways. There's an argument to why it is not a part of that as well. The next family, which is going to be your calciums and your magnesiums and your strontiums, these are members of the alkali earth metals. Region 3 is this whole group here between the two larger ends, and those are referred to as the transition metals. So the transition metals are those metals here between 21, this is all this blue, light blue section in here. Then after that, the families don't have real names after that. You go by their group numbers. And so I don't have the group numbers up here at the top. So let's start over here. This is group 1, 2, and so this would be group 12. So group 13 is the boron family. And group 14 is the carbon family. And group 15 is the nitrogen family. And group 16 is the oxygen family. Group 17 has its own name. And group 17, which I've marked with a 4 right here, this section are called the halogens. So this is your fluorine, your chlorine, your bromine, your iodine. You've probably heard of halogen light bulbs. Halogen light bulbs are called halogen light bulbs because what produces the light in there are a mixture of halogen gases. The group I've numbered 5 here, these are the noble gases. Noble gases referring to the idea of they don't bond. They're sort of special gases. So think of nobility and how they think they're special and they don't behave like the common folk. We'll find out later on why that's true, but basically they have full outer shells to start with. All right, now down here we have 6, 7, and 8. Now instead of being vertical columns, I have horizontal rows here. And so we're starting here with 57. Mine starts with 57 lanthanum. This row right here is referred to as the lanthanides. It begins with lanthanum, and so it's the lanthanides. And so guess what? Row 7 is called the actinides because it begins with actinium. You can group 6 and 7 up, and you can refer to these as the rare earth elements. I forgot to mention at the very beginning that rows on the periodic table are called periods. So you have period 1, it has 2 elements in it, and period 2 that has 8 elements in it, period 3 that has 8 elements in it, and period 4 that has 18 elements in it, etc. The columns run up and down, and these are called families. Starting back here in the top left, groups 1 and 2, the alkaline earth metals and the alkaline metals can be grouped together into group S. And this is called a block of the periodic table. So this is called S block. We'll find out later on why it's referred to S block. I'm going to remind you of this particular day when you were talking. Over here to the right, you have the P block, which I have included helium into, although there's reasons later on in chapter 4 where we'll find out why helium is actually probably not part of the P block. But I've just included it here for simplicity. Everything from the boron family all the way over to the noble gases, this is P block. Section 3 is the same thing as the D block, and this is called the D block, the transition metals that you just learned. And then the rare earth elements that we just learned about, that's the F block. So those are your major sections of the periodic table. Now I should mention that you saw on my periodic table here, if I bring it up again, there's a little set of asterisks here. The lanthanides and the actinides have been yanked out of the periodic table. And the periodic table could actually be lengthened, but for space-saving purposes, they are usually not lengthened. I'll zoom out here a little bit so you can see most of the whole periodic table here on one screenshot. The F block has been removed from there and put down here, but technically it's supposed to go here where the asterisks are. An overall look at the periodic table then, if you notice, it should look a lot like this here, with the lanthanides put in that particular spot. So there's the long version of the periodic table. They're usually not included like this because you see you got a gap between the group numbers. So you got group 1 and 2, and then group 3 starts over here at titanium, and this doesn't line up very well. Group 4 is vanadium, etc.